Well, let's go ahead and apply the root test here. We see that there is a power up in the exponent position that will lend itself to using the root test. So we are going to form rho equals the limit as k goes to infinity of the kth root of the absolute value of a sub k. Now, a sub k in this instance is positive, so we do not have to put in the absolute values. So we will be taking the kth root of all of that. Well, the kth root of all of that is found by taking 4k squared and multiplying it by 1 over k, or dividing it by k. We will end up with k over k plus 5 raised to the 4k power. Now, this is going to be evaluated using a different technique. We can't evaluate this limit directly as is. It's an indeterminate form. The inside here is going to 1. The exponent is going to infinity, and 1 to the infinity is indeterminate. Now we're going to do this in a different way in the sense that we have already established the following limit. We know that the limit as k goes to infinity of 1 plus capital A over k to the bk power, we've already shown using the log limit process that this becomes e to the ab. And so what we're going to try to do is rewrite our expression here to fit this form. And here's what we'll do. We are going to flip the fraction on the inside, because we can then split the fraction. But if we flip that fraction, the exponent has to change signs. We can then divide the k into the numerator on the inside, giving us 1 plus 5 divided by k, all raised to the negative 4k. Now, if we look at our template up here, we now have that capital A is 5, the numerator here, and capital B is negative 4. So, using our template up there, we know that this limit is going to be e raised to the 5 multiplied by negative 4. So that will be e to the negative 20, which if we want to write it with no negative exponents, sometimes it's easier to analyze without negative exponents, we have that. And just like the ratio test, we compare this to 1, or the geometric series, we compare to 1. This is less than 1. And with the geometric series, or the root test, or the ratio test, when you have a value that's less than 1, you end up with convergence. So therefore, this series is going to converge.